Now, for this one, standard deviation. PS, probability of statistics, standard 7. On the standard deviation of these 4 data. Now, for the standard deviation, the first thing you do right here is you first have to find the mean of this data, the average. And the way you find the mean or average is you add it up, divide by how many terms. So you add those up, divide by, because there's 4 terms, and I get 5. That's your average. Then what I do is I take each number, see right here, each number, and I subtract the red, the mean. So I take the first number, subtract the mean, second, subtract the mean, and so forth. And as you can tell, square them. So you find the difference from the mean and square it. And then you average it, meaning all those values you divide by 4 because there were 4 values. Once you do that, it breaks down. So here you squared it, you subtracted them, you squared them, break it down, and inside you end up with 15 over 2. The whole thing ends up being square rooted. That is a fine answer. You can leave it like that. Now, if it's a multiple choice, sometimes they'll make you get one of these 2 answers. So make sure you can break it down on a multiple choice test. Because hopefully you know this is 7.5, and hopefully you know 7.5 is somewhere between 9 and 4. So square root of 9 is 3, square root of 4 is 2. So somewhere between, between 2 and 3. That's approximately the answer. Little squigglies mean approximately. So again, you just got to remember this formula where you average, subtract it from each term, the average that after you square them all, and then don't forget the square root. This value describes how spread the data is, which that's number 2. Which one would have the largest, which would have the smaller standard deviation? Well, which one is the most spread out, which one is the most united data? So if you think of this as a number line, if you put all this, like for instance this one on a number line, and then you go, okay, which of these, when you put these sets of data separately on number lines, which ones are closest together, which ones are most spread out? So out of these 4 sets of data, which is the farthest spread out? Well, that looks like A. That's why it's the largest standard deviation. A looks like the largest spread out. It goes from a 5 to a 97. The data is just all over the place. Where B is the smallest, because if you look at this, look at all 3 sets of data. Isn't B have the closest united numbers? The numbers are closest together on a number line. So that's kind of the basic idea of how to spot big or large standard deviations. Depends on how spread out the data is. And number 3 is variance. Well, variance is the same exact thing as standard deviation, except you didn't square root it. See how the square root's missing? That's all it is. It's kind of almost dumb because it's the same thing. So we basically, with this data, we find the mean, which right here. We found the mean. We add them up, divide by how many terms. It's got 6. I then take and each number, here's all the numbers, subtract the mean, square, subtract the mean, square, and so forth. Keep the pattern. Divide by 5 because there's 5 numbers. And I end up with 86 over 5. Make sure you reduce it if you can. If you don't reduce, you'll be wrong. But you don't square root it. Sometimes you might have to put this as a decimal, if it's a multiple choice possibly. But that's the basic idea of the variance is basically the number inside of the square root. So for this one, it'd be 7.5. Or 15 over 2 would be the variance.